Hello guys, this is Daniel and today we're going to continue with our token sessions in Vyper. Remember that for these sessions you really need to have some knowledge of Brownie, so if you don't have any knowledge on Brownie, go back to our previous series, watch the Brownie videos and then return to this series to be able to implement everything that we are doing. Now we are already in our Brownie folder of the My Fungible token, and we are working with this Hello World coin. In the last video, we make this coin be compliant with the ERC20 standard, but still, regarding some aspects, this coin is still a little bit naive. And one of those aspects is the supply. And we would like to illustrate one way here that we could make the supply a little bit more dynamic. To do that, we are going to eliminate this total supply that we have here, and we are going to create a mint function that, in the case of the supply mechanism that we are going to implement, is going to be only available once and only available to the deployer of the contract, and will be the function that actually sets the total supply of the token. So there are different scenarios where you might want to have this type of minting function. Maybe you might need to have a more sophisticated implementation in which you allow several people to be minters and you allow certain events to actually trigger the minting of more tokens and other use cases like that. But for now, we're going to keep it very simple. So it's going to be minting only once and only to the owner of the contract. Now, for that, we are going to erase this total supply variable that we have here. And we are going to make that total supply a variable. So we are going to create that here. We're going to have a total supply variable. And this variable is going to be a uint 256. Then we are going to allow this minting function that we are going to create only to be available once. So we're going to have this minted boolean, which is going to allow us to call that function only once. It's going to be initialized to false, but after we take the minting function active, it's going to be set to true, and we are going to set some check there to not allow us to call it again. We are going to have this minter, and this is going to be an address. And here, what we are going to do is define who that minter is at the moment of the deployment of the token. So we are not going to set the supply at this moment, but we're going to tell self minter equal to message sender. This is going to set that the deployer is the minter, and we're going to set also the self minted, though these ones are for the by default booleans are initialized to false, but we're going to make it explicit. So we're going to do self minted is equal to false. Now we need to create our minting function, right? So we are going to create an external function, and it's going to be on top of these external functions that we have created until now. And we are going to do the following. We are going to do a def mint, and it's going to take a 2 because we might let that deployer of the contract decide who is going to be the initial owner of all the supply. We are going to pass the T supply, which is the amount of tokens that we want to create. And this one, since it's external, we're going to make it boolean, so it returns true when everything is said and done correctly. Now we are going to have a couple of assertions here. The first one is that we want to make that only the owner or the deployer of the contract is going to be able to mint, right? So we're going to have message sender is equal to self minter. And if this is not the case, we're going to say only owner can mint and only once. And then we're going to share another assertion here that is going to say self minted equal to false. If not, we are going to say this token has already been minted. And we have these two checks there. Now is something very, very simple. So we are going to say self total supply, which is the variable that we just created, is equal to t supply, which is the parameter that we are going to pass when this function is called, times 10 to decimals. So what we're doing here is that we're making it a little bit more convenient when we call the function. So we don't have to be saying 10 to the 18 or all of those things that we have been doing manually. Here we're just going to set how many tokens of our tokens we want, and then all the amount of decimals are going to be added here by this minting function. Now we're going to transmit the balance, and we're going to say balances to, which is the address that is going to receive the minted tokens. It's equal to self total supply, and then we are going to set this one to true because the token at this moment would have been already minted. And we're going to do something interesting here. We are tracking events right now to keep the activities of our token, right? So actually, to be more clear on how this chain of events is happening, we are going to define that this first minting is happening from the 0 address, which is a constant that Vyper offers. It's basically, think of it as an empty set. And from this 0 address, we're going to say that it was transferred to 2, which is the address that we are sending the funds, and what we sent was the self total supply. So we're tracking that event. And that's it, but we need to do a little bit more. And we need to do a little bit more because we are allowing the events to track the 0 address. So we don't want that 0 address to have other events related to it. So in the approval internal function that we have here, we are going to assert that the owner is different than 0 address. And we are going to assert that the spender is also different from 0 address, because basically the 0 address should not have any balances. We are using it only as a proxy to create this initial supply out of nowhere. So that's it. But if we do that, we also need something similar here in the transfer internal function. So we're going to set the from should be different than 0 address, and the to also should be different than 0 address. And this is just housekeeping. It's just to allow us to use that 0 address as the source of our minting. Now that we have that, then let's deploy our contract. And we have something here we forgot after sending this event that we have to return true. And we have a property here that is that this function is external. So let's check it out. Yeah, the supply should be like this. And then this total supply should be returning not the constant, because the constant doesn't exist anymore. It's going to be the total supply variable. So it's gonna be self total supply. Now we're in. Let's do our deployment again, as we have been doing. From account 0, we deploy, we have our contract now. Now we're going to set a balance of accounts. And remember that before, account 0 had all the balance. And instead of balance of, we do total supply. Is going to be 0. So our token doesn't have any supply right now. Now we're going to call our mint function. And this mint function takes the following. Who is going to be the address? So let's mint to accounts 0. Then we need to define what is the total supply. And remember that here we don't have to define all the decimals, only the integer part of our token. So let's say that we want 1,000,000, right? And that's 10 to the 6. So let's do 10 to the 6. This is 1,000,000 tokens. And with the 18 decimals that we already defined as part of our constants in the contract. And then we are going to say accounts 0. Let's deploy. Now we go to total supply and let's divide it by 10 to the 18, which is the amount of decimals that we have. And here we have 1,000,000 tokens minted. And then if we go to the balance of account 0, and let's do the same to just check the integer, all the 1,000,000 tokens went to the account 0. So that's the way, guys, that we create a supply in a very naive way, but you can play around with this minting function to have a more complex logic or a more game theoretical model to supply your tokens, have airdrops and whatever you want to do. So thank you very much, guys. Subscribe to the Moralis channel and see you in the next video.